Hello and welcome to this introduction video and manual on the Jellyfish micro quadcopter frame. The Jellyfish is a very compact 3D printable 45mm size micro quadcopter frame for brushless motors, tiny hoop style all-in-one mainboards, and regular all-in-one FPV camera and video transmitter units. The purpose of this video is to provide you with all the information you need to successfully print and build the frame, and of course to get it airborne. This video has 3 sections. Links to each of these 3 sections are provided in the video description below. In the first and shortest section, I will briefly talk about 3D printing the Jellyfish frame parts. In the second section, I will walk you through building up a complete Jellyfish, including electronics. In the third part of this video, I will cover the basic electronic setup in Betaflight. This part of the video is very important. Since we are dealing with a push-prop setup and an altered flight controller orientation, it is very important to get this basic setup right. One mistake and your Jellyfish will simply not lift off. I hope you enjoy this video. If you have any feedback or questions, feel free to post it in the comment section below. Or check the video description for a link to the contact page on my website. Thank you and happy flying! Alright, let's take a look at the 3D printing section of the Jellyfish video manual. When you download the Jellyfish 3D print files from Thingiverse, you will receive a zip file containing 9 STL files. As you can see here, the regular ARM file needs to be printed 3 times. All other files are only to be printed once. You also get to choose between 2 different battery mount sets. The 1S battery mount set has been designed for a 1-cell LiPo battery setups or a 2-cell LiPo battery setup with 2 separate 1-cell LiPos. The 2-cell battery mount set has been designed for regular 2-cell LiPo batteries. For the example that I'm going to build in this video, I will be using a 1-cell LiPo battery setup. Let's take a look at our slicer. As you can see, I have already made a layout with all the parts to be 3D printed. As I said before, the regular arms are to be 3D printed 3 times. The other parts only once. The Jellyfish has been test printed with ABS, PETG and PLA. I consider all 3 of these filaments to be usable with the Jellyfish. Of course, durability and flexibility of the frame will depend on the filament that you're going to use. I do not recommend using a flexible filament for a Jellyfish, for example TPU. The frame has not been designed at all for these kinds of filaments. All parts of the Jellyfish are to be printed on the horizontal axis of the print bed. Horizontal axis, the x-axis, however you want to name it. Let's take a look at our print settings. Support 0. You don't need any support for a Jellyfish. The frame has been designed in such a way that no support is needed and small holes can easily be bridged by any 3D printer that is available today. Nozzle diameter. For a nozzle diameter, I recommend a 0.4mm nozzle or lower. For the layer height, I recommend to set up a 0.2mm layer height or less. With a 0.2mm layer height, you can print a Jellyfish frame kit, including the camera mount, in about 1 hour. I consider that pretty fast. Of course, you can also choose to go lower to, for example, a 0.1mm layer height. The lower you go, the more precise your print will be. For the Jellyfish, you need no infill at all, 0. What you do need are a few top layers and a few bottom layers. I think this is about all I can say about 3D printing a jellyfish. I consider it a very easy print for most printers that are available today. Now, let's get these parts printed out, and then we can continue to building a fully working jellyfish. Alright, now let's get started building a jellyfish. This part of the video I will be doing a little photo slideshow while explaining everything that needs to be done. Okay, let's get started with everything here that we need. Of course, we have our 3D printed parts right here. We have our shroud, motor block, camera mount, the regular arms, the USB arm, and the 2 pieces of the battery mount. For electronics, I will be using a CrazyBee F3 board, which has been working very well for me, a regular all-in-one camera and video transmitter unit for FPV. Of course, you can also use a separate camera and video transmitter because the camera will be mounted on the mount with its lens. For the motors, I am using TinyWhoop 0802 19,000 kV motors. Furthermore, we have our regular hardware here. We have 4 grommets for the flight controller. We have our motor screws and our flight controller screws. We have our little screwdriver right here. We use a little bit of CA glue, optionally a sharp knife in case that could be necessary, and a pair of cutting pliers. Let's get started. First of all, we are going to install the motors on the motor block. For this build, I would like the USB port of the flight controller to be on the rear left of the frame. So I'm going to position the motor block already like that. Now, there is some very special, very important information that I have to share here. We are building a push prop setup, and I would like a props out setup. That means we want a clockwise rotation on the front right, a counterclockwise rotation on the front left. Okay, but because we are installing our motors upside down, we have to reverse the rotation of these motors. So that means for a clockwise rotation, we need a counterclockwise turning motor with clockwise propellers mounted top first on the motor shaft. I will repeat this once again. For a clockwise rotation, we want a counterclockwise turning motor with a clockwise propeller mounted top first on the shaft. It is very important that you do this right, because if you make mistakes here, your jellyfish will simply not fly. For counterclockwise rotations, it's pretty much all the same. For a counterclockwise rotation, you need a clockwise motor with counterclockwise propellers mounted top first on the shaft. Let's continue. Here I have installed the motors on the motor block. There's nothing much to tell about it right here. The only thing that you need to check is if the propellers are not touching each other and that they are about an equal distance away from each other. Here we can see that everything is pretty much okay. Now we can put our motor block aside for a while, and we're going to start with our shroud and arms. As I said before, I want the USB port of the flight controller on the rear left of the frame. Therefore, I'm going to install my USB arm also on the rear left of the frame. Installing the arms is fairly easy. All you have to do is push them through the slot in the shroud right here until you can no longer continue. At the underside of the shroud, a little piece of the arm will protrude. This is perfectly normal, and we will deal with that later. If you have any difficulty installing the arm in the slots, use your small knife to clean out the slot hole right here in the shrouds. Since the frame is 3D printed, it is always possible that there is a little bit of rubble left inside these holes that prevent you to fully install the arms. Here you can see that all the arms are installed, and we are getting ready to install the camera mount. The camera mount is installed in a similar way like the arms are installed, but the camera mount has a 20-degree angle. And just as with the arms, the camera mount will be protruding a little bit through the bottom of the shroud. I say it again, don't worry about that. We will deal with it at a later stage of the build. Good. Now it is time to put the motor mount together with the rest of the frame we have just prepared. On the motor block, at each motor mount there is a vertical slot and a horizontal slot. The vertical slot has been designed to accommodate the vertical strut here on the arm. The horizontal slot right here has been designed to accommodate the horizontal strut right here. This is very easy, really. And here magic happened. The motor mount has been fused with the rest of the frame. As you can see, the struts are fitted in their respective slots. You may notice during your Jellyfish build that at this stage in the build, the motor block is not 100% firmly fit in the frame. This is perfectly normal, and this will be solved as soon as the flight controller and the battery mount are screwed in place. Now we are going to install the battery mount. I suggest you first start with one piece of the battery mount and screw it in the frame only on one side. You use a flight controller screw and a I lost the name, and a grommet, of course. Next, we are going to take our second part of the battery mount, and we also install this one only on one side in the frame. That way, the back side of the frame remains open to install the flight controller and the camera inside. Good. Now to install the camera and the flight controller unit. The camera, as I said before, will be slotted in the camera mount with its lens. Fairly easy. If you find, for one way or another, that the camera is not firmly in place, you can also use a small zip tie through a hole below the main camera mount. In a later stage of this video, I will show you how to do that. It has been designed to optionally install a small zip tie, but it is not truly necessary. For myself, I don't do it, but you can if you want. The flight controller has been partially installed. As you can see, the corners of the flight controller are seated in the grommets like they would be in a regular tiny hoop setup. Now it is time to close up the back of the frame. We are doing this the same way we did at the front, using a screw and a grommet, like you can see on this picture. Now the frame is completely closed up and everything should fit firmly together. All that's left to do now is to install the motor connectors into their respective motor connectors on the board. It is important to know that in a Jellyfish build, the flight controller will usually be at a 45-degree different orientation compared to a regular whoop. Because of that, the motor connectors on the board will also be shifted 45 degrees. It is important that you install the motor connectors, the connectors of your motors, into the right connectors on your board. You can do it, or you can also remap the motor connectors into Betaflight later on. For myself, I choose to install the motor connectors the regular way. So for me, that means that the front right motor will be connected to the motor connector right here. The front left motor will be connected to the connector below the board right here. The rear left motor is going to be connected to the motor connector below here. And the rear right motor is going to be connected in the motor connector below here. As a final step in this build, as I said before, let's return a little bit. Return. As I said before, the arms of the Jellyfish frame, together with the camera mount, protrude a little bit through the bottom of the shroud. Now it is time to check if everything on your frame is straight and firmly fit together. And then you take your set of cutting pliers and you cut away these excess parts. Then you will end up with something like this. Then all that's left to do is to apply a little drop of CA glue on each corner, on each connection point with the arms, really, and on the connection point with the camera mount. It is not necessary to use any glue on the motor block, on the joints on the motor block. That way you will have an easier time removing or replacing the motors if that is ever necessary. If you want to replace or remove a motor, all you have to do is unscrew the screw at the flight controller on the side of the motor that you want to replace. After that, you can just pull out the vertical strut here of the arm, and you can put it aside, and you have easy access to the motor screws that are here. Good. Our frame is ready for the basic Betaflight setup that we are going to do next in order to get the Jellyfish finally airborne. Oh, silly me, almost forgot. I still need to talk about the zip tie and the camera mount. If you would like to tighten your camera a little bit more on your camera mount, you can use a small zip tie. I have designed a small hole here in the camera mount, which allows you to feed through a zip tie All you have to do is feed through the zip tie, wrap it around the camera lens, and then after you tighten it up, you take your cutting pliers and cut off the excess part. That's all there is to it. Now off to Betaflight. Alright, let's start with our basic Betaflight setup part of this instructional video. I am not going to do a complete Betaflight walkthrough in this video. There are loads of good tutorials and video manuals already available on the internet to cover that. What I am going to explain here is everything that is important for the Jellyfish in particular. So I have connected my Jellyfish to my laptop and we're going to connect. Alright, let's go to our configuration tab in Betaflight. Good. In this configuration tab, there are two things that are of utmost importance for a Jellyfish. First of all, I'm going to start with the board and sensor alignment. As I said in the build section of this video, the flight controller is not in a regular orientation as you would have it on a tiny whoop. Instead, the flight controller has a 45-degree orientation difference on the jaw axis. It is important that you set that up in Betaflight, as you can see right here. If you want your USB port of the flight controller on the rear right of the frame instead of the rear left that has been used in this example, you would need to use a minus
45-degree orientation on the jaw axis. Very important. We're going to check in our setup tab if the orientation is right. So turn my quadcopter, green is a front. I'm going to do a little front and back movement on the elevator axis, and you see everything's going right. Okay, now I'm going to move to the left and to the right. On the aileron axis, everything is good. On the rudder axis, left, right. As you can see, everything is great. Now let's head back to our configuration tab. The second important part of our Jellyfish basic setup is the motor direction. And yes, I'm going to repeat this once again. You'll probably get bored of me. It is important that you need to get this right. If you don't get this correct, your Jellyfish will not fly at all. Good. In my example, I want a props out setup. What you see here is an example of props out. If you want props in, you just reverse here and you get a props in. But I want props out, so here we are. I say it again. We are using a push prop setup. That means the motors are mounted upside down on the frame. Because of that, if we want a clockwise rotation, as seen right here, you see it from the top of the frame, just to mention. If you want a clockwise rotation like you see here, you need to use a counterclockwise motor with a clockwise propeller mounted top first on the motor axis. If you want a counterclockwise rotation, you need a clockwise running motor with a counterclockwise propeller mounted top first on the motor axis. This is important. This is really important. Good. Now I'm going to connect the battery and we are going to check in our motor tab if all motors are connected to the correct motor connector on our flight controller, and if our rotation is going in the right direction. For this, I'm going to boot up my webcam. Alright, I have just connected a flight battery to my Jellyfish because we need to do that in order to test the rotation of the motors. I'm going to show you my Jellyfish right here. The front is here where the camera is seated. What will I do? I will turn each motor one by one and see if they run in the right direction. For starters, I will turn motor 1, which is supposed to be the rear right motor here. We want a counterclockwise rotation, so I have used a clockwise motor mounted upside down with a counterclockwise propeller mounted top first on the axis. As you can see, this motor runs correctly. Motor 2 is the front right motor. Here we want a clockwise rotation. So for that, we have a counterclockwise motor mounted upside down with a clockwise propeller mounted top first on the motor axis. And we have a clockwise rotation as we want. Motor 3 is the rear left motor, but because my USB cable is right here, I am not going to test this motor. I do not want to burn it or my ESC, of course. Let's go directly to motor 4, which is supposed to be the front left motor. We want a counterclockwise rotation, so we want a clockwise motor with a counterclockwise propeller mounted top first on the shaft. I know you will get bored of me, but I keep repeating it because it is so important. Let's power up the motor. And the fourth motor is running correctly as well. Good. If for whatever reason you want to remap your motors, that means if you want to connect one or more of your motors to a different motor connector on your flight controller, you can set that up through the CLI command box here in Betaflight. I am not going to go through the whole process of doing this. Instead of that, I will link a very good guide on it in the video description below. This guide has been made by a guy named Oscar Liang. I hope I pronounce his name right. And I have used this very same guide to get my first steps into Betaflight. If for whatever other reason you want to reverse the direction of the motors you have, you need the BL Heli configurator. I'm going to quickly load that up to show you right here. There we go. You have to click Read Setup. Just like that, and here you can see all your 4 ESCs. In order to reverse your motor direction, all you have to do is, instead of normal, you choose reversed and then right setup, and you're done. Alright, it's time to wrap up this instructional video on the Jellyfish micro quadcopter frame. I did my best to provide the necessary information that you need to successfully print and build the Jellyfish, as well as doing the necessary programming in Betaflight.
If you wish to provide any feedback to me or you have any further questions, feel free to visit the contact page on my website, which I linked below in the video description. You are also free to post a comment on the Jellyfish page of Thingiverse. All that's left for me to do now is to wish you happy flying with Jellyfish, and good luck and have fun with everything else that you do. Robbie out, bye bye, see you next time.